of metals. Their physical properties are hard and have a high tensile strength. Solids at room temperature. Sonorous. Good conductors of heat and electricity. Malleable. Means, can be beaten into thin sheets. Ductile. Means can be drawn into thin wires. High melting and boiling points, except cesium, Cs, and gallium, Ga. Dense, except alkali metals. Osmium highest density and lithium least density. Lustrous. Silver gray in color, except gold and copper. Nonmetals. Nonmetals are those elements which do not exhibit the properties of metals. Physical properties are occur as solids, liquids, and gases at room temperature. Brittle. Non-malleable. Non-ductile. Non-sonorous. Bad conductors of heat and electricity. Some exceptions in physical properties are alkali metals can be cut using a knife. Mercury is a liquid metal. Lead and mercury are poor conductors of heat. Mercury expands significantly for the slightest change in temperature. Gallium and cesium have a very low melting point. Iodine is nonmetal but it has luster. Graphite conducts electricity. Diamond conducts heat and has a very high melting point. Reaction of metals with oxygen. Metal and oxygen gives metal oxide, basic. When sodium and potassium are kept immersed in kerosene oil as they react vigorously with air and catch fire are called vigorous reaction. Reaction goes as follows. Next, magnesium, aluminium, zinc, lead react slowly with air and form a protective layer that prevents corrosion. Magnesium burns with white dazzling light. Here is some example of reaction. Silver, platinum, and gold don't burn or react with air. Basic oxides of metals. Some metallic oxides get dissolved in water and form alkalis. Their aqueous solution turns red litmus to blue. Amphoteric oxides of metals. Amphoteric oxides are metal oxides which react with both acids as well as bases to form salt and water. For example, aluminium oxide, zinc oxide, lead oxide, tin oxide. Some amphoteric oxides of metals reaction are reaction of metals with water. Metal and water gives metal hydroxide or metal oxide and hydrogen. Next, reaction of metals with acid. Metal and dilute acid gives salt and hydrogen gas. Only magnesium and manganese react with very dilute nitric acid to liberate hydrogen gas. How do metal react with solution of other metal salts? Metal A and salt of metal B gives salt of metal A and metal B. Reaction of metals with bases. Base and metal gives salt and hydrogen. Reactivity series. This is the chart where reactivity of metals decreases when we going from top to bottom. How do metals and non-metals react? Metals lose valence electrons and form cations. Nonmetals gain those electrons in their valence shell and form anions. The cation and the anion are attracted to each other by strong electrostatic force, thus forming an ionic bond. For example, in calcium chloride, the ionic bond is formed by oppositely charged calcium and chloride ions. Calcium atom loses 2 electrons and attains the electronic configuration of the nearest noble gas, Ar. By doing so, it gains a net charge of +2. The 2 chlorine atoms take 1 electron each. thus gaining a charge of -1 each, and attain the electronic configuration of the nearest noble gas, argon. Ionic compounds and its properties. Physical nature. Ionic solids usually exist in regular, well-defined crystal structures. Electric conduction of ionic compounds. Ionic compounds conduct electricity in the molten or aqueous state when ions become free and act as charge carriers. In solid form, ions are strongly held by electrostatic forces of attractions and not free to move, hence do not conduct electricity. For example, ionic compounds such as NaCl does not conduct electricity when solid, but when dissolved in water or in a molten state, it will conduct electricity. Melting and boiling points of ionic compounds. In ionic compounds, the strong electrostatic forces between ions require a high amount of energy to break. Thus, the melting point and boiling point of an ionic compound are usually very high. Solubility of ionic compounds. Most ionic compounds are soluble in water due to the separation of ions by water. This occurs due to the polar nature of water. For example, NaCl is a 3D salt crystal composed of Na and Cl ions bound together through electrostatic forces of attractions. When a crystal of NaCl comes into contact with water, the partial positively charged ends of water molecules interact with the Cl ions, while the negatively charged end of the water molecules interacts with the Na ions. This ion-dipole interaction between ions and water molecules assist in the breaking of the strong electrostatic forces of attractions within the crystal and ultimately in the solubility of the crystal. Occurrence of metals. Most of the elements, especially metals, occur in nature in the combined state with other elements. All these compounds of metals are known as minerals. But out of them, only a few are viable sources of that metal. Such sources are called ores. Gold and platinum exist in the native or free state. Extraction of metals. Steps involved in the extraction of metals from their ores is dependent on the reactivity of metals. Roasting converts sulfide ores into oxides on heating strongly in the presence of excess air. It also removes volatile impurities. Calcination converts carbonate and hydrated ores into oxides on heating strongly in the presence of limited air. It also removes volatile impurities. Extracting metals low in reactivity series. By self-reduction, when the sulfide ores of less electropositive metals like Hg, Pb, Cu etc. are heated in air, a part of the ore gets converted to oxide, which then reacts with the remaining sulfide ore to give the crude metal and sulfur dioxide. In this process, no external reducing agent is used. Extracting metals in the middle of reactivity series. Smelting it involves heating the roasted or calcined ore, metal oxide, to a high temperature with a suitable reducing agent. The crude metal is obtained in its molten state. Aluminothermic reaction, also known as the Goldschmidt reaction, is a highly exothermic reaction in which metal oxides, usually of Fe and Cr, are heated to a high temperature with aluminium. Extraction of metals towards the top of the reactivity series. Electrolytic reduction. 1. Downs process. Molten NaCl is electrolyzed in a special apparatus. At the cathode, reduction. Na and an electron minus gives Na. Metal is deposited. At the anode, oxidation. 2Cl minus gives Cl2 plus 2 electron minus. Chlorine gas is liberated. 2. Hall's process. Mixture of molten alumina and a fluoride solvent, usually cryolite, Na3AlF6, is electrolyzed. At the cathode, reduction. 2Al3 plus and 6 electron minus gives 2Al. Metal is deposited. At the anode, oxidation. 6O2 minus gives 3O2 plus 12 electron minus. Oxygen gas is liberated. Enrichment of ores. It means the removal of impurities or gangue from ore, through various physical and chemical processes. The technique used for a particular ore depends on the difference in the properties of the ore and the gangue. Refining of metals. Refining of metals, removing impurities or gangue from crude metal. It is the last step in metallurgy and is based on the difference between the properties of metal and the gangue. Electrolytic refining. Metals like copper, zinc, nickel, silver, tin, gold, etc., are refined electrolytically. Anode, impure or crude metal. Cathode, a thin strip of pure metal. Electrolyte, aqueous solution of metal salt. From anode, oxidation, metal ions are released into the solution. At cathode, reduction, the equivalent amount of metal from solution is deposited. Impurities deposit at the bottom of the anode. Corrosion. Gradual deterioration of material, usually a metal, by the action of moisture, air, or chemicals in the surrounding environment. Prevention of corrosion. 1. Coating with paints or oil or grease. Application of paint or oil or grease on metal surfaces keep out air and moisture. 2. Alloying. Alloyed metal is more resistant to corrosion. Example, stainless steel. 3. Galvanization. This is a process of coating molten zinc on iron articles. Zinc forms a protective layer and prevents corrosion. 4. Electroplating. It is a method of coating one metal with another by the use of electric current. This method not only lends protection but also enhances the metallic appearance. Example, silver plating, nickel plating. 5. Sacrificial protection. Magnesium is more reactive than iron. When it is coated on the articles made of iron or steel, it acts as the cathode, undergoes reaction, sacrifice, instead of iron, and protects the articles.